Hey, welcome back. As I promised here, we're going to go through the code that does those things that we were talking about. So, as always, make sure that you've imported Pint and ModSimPy. And then we're also going to re-import all this code from before. We have to define the step function. We have to define bike to Wellesley, bike to Olin. Here's a decorate bike share, but the key thing to notice here is we are indeed passing in the value of the state, the current bike share, and that means we also need bike to Wellesley and bike to Olin to keep track of what the state is as well. Let's look at this modified version of run simulation. This is slightly different than what I talked about in our in the video, so let's change it a little bit to match better what we were talking about. So in this version of run simulation, it takes into account just the probability P1, P2, and the number of steps, and it actually creates a base state object inside the run simulation. So if you remember what we did in class is, in the previous video, is we didn't have this inside the run simulation, we had it outside the run simulation. So I'm going to delete it, and I'm going to put state as one of the arguments here, one of the inputs for the simulation. So now in order to call run simulation, we first need to create our bike share object. So we get bike share equals this state object, and then we run our simulation on bike share 0.4, 0.260. Alright, it doesn't do anything, but we can get the information out of it, how many times there were unsatisfied customers at Olin. Let's run it another time and see if that changes. Yes, it does. Here we got 5 unsatisfied customers. Right, and so the goal here is to say, if we now take this and we modify some of the parameters. So let's say we have a different probability of how many bikes are leaving Olin and how many bikes are leaving Wellesley, then we can just put these all in one code block, and this is giving us the information. Each time we run it, we're running a new simulation. Right? And so the goal is that if this probability, let's say it's unlikely that bikes go from Olin to Wellesley. Well, then if you show up at Olin, there's probably going to be a bike available for you. However, if, on the other hand, the bikes at Olin are very hot right now, right? Then what you would say is take this. The bikes are often being taken away from Olin and not often being replenished with bikes back from Wellesley. Well, in that case, there's probably going to be a lot of demand, and so there'll probably be a lot of these bikes that times when the customers are unsatisfied. So we're going to keep track of that using the SweepSeries. So let's take just a short amount of time to talk about Linspace. Right, so we brought that up in the previous video. The goal for Linspace is to say, if we have some initial value of a parameter and some final value of a parameter, and we'd like to create 5 distinct units along the way from 0 to 1, like 0, 0.25, 0.5, 0.75, 1, we can use the Linspace command. And so this is really good for creating a equally spaced set of numbers that you specify the number of numbers you want, and it does the calculation for you, so you don't have to do that. So let's now go in and sweep the parameters. So let's just go directly to the way we set this up before. So what we want to do is this. We create a sweep series. We don't have to initialize, we don't have to put the value of the sweep series at 0 like we did with the time series, because we're not a building on it. But furthermore, we don't actually know what the value is at the initial p-value until we run the simulation the first time. Here, now we put in our bike share. So we have, so actually this has to be inside the for loop. Sorry about that. So what do? We create our sweep series. Make sure this matches what we had on our previous set of notes. Yes, we have our sweep series. Then we need to create our P1 array. So we need P1 array, and we're going to specify exactly which values of P1 we want to visit. So here we decided 0 to 1 with 11 pieces. So we're starting off at 0 and going 0.1.2 up to 1.0. We're specifying what P2 is. P2 is 0.2, and then num steps is equal to 60. And so by doing that, we now run our bike share, we run our simulation with P1, P2, and the number of steps that we've specified. And it runs through it. It gives us what the value is at P1 is equal to 0, what the value is when P1 is equal to 0.1. And then we can plot, and we can see what that looks like over time, not over time, over the different values of P1. And here you can see when P1 is small, it's unlikely that there's an unhappy customer. But when P1 is basically 100%, so somebody's taking a bike every single minute, then you expect there to be a large number of unhappy customers. Here we've even made it up to 40 unhappy customers. Let's run it one more time and see how it compares. If we run it a second time, again, it has the same type of we'll reach exponential, parabolic. We could probably do some math and figure out exactly the shape of the curve. But you can see here that the trend is evident as the probability that somebody's going to take a bike increases, then the number of unhappy customers also increases at that place. All right, let's stop there, and I'll see you next time.